x to the 4, and then, oh, I forgot the c right here, right? So I write at the end. And then what? X to the 4 or x cubed already. X to the 4 becomes plus 1/5. X to the 5th and minus da da. Okay, and don't forget you have plus c. So usually people write plus c in front so they don't forget. So let me write c in here. That's the same c as that one right there. Okay. So you're almost done. The function ln of 1 plus x can be written that way. Okay. No, plus c this side. Okay. So let me write it up here so you can see. Ln of 1 plus x can be equal to x minus 1/2 of x squared plus 1/3 x cubed minus 1/4 of x to the 4 plus then plus c at the end. C could be a positive or negative number, could be on any side. Okay, c here, c there, a different c, and we move from one side. C stands for constant. That's it. Okay, could be positive, could be negative. So you don't have to ask, or you don't think of what this could be minus c or plus c, because c positive or negative could be included in that c. So writing plus or minus in front won't be matter. So the function ln of x plus 1 can be represented as a power series plus a constant. So the last thing that we have to do is figure out the constant. How to figure out the constant? Just plug in the center values. Try x equal to, center is x equal to 0. Power series center is 0 for sure it's convergent. X equals 0. So ln of 1 plus x equal to ln of 1, which is equal to 0. You plug and go to 0 right here. So 0, 0, 0, 0 is equal to c. So c is equal to 0. Okay? Then you have your power series. So ln of 1 plus x will be x minus 1/2 of x squared plus 1/3 of x cubed minus 1/4 of x to the 4 plus forever. And that's c equals 0. I tried to write c at the end right here, but actually in my opinion it looks awkward. Usually people write c in front. Okay? Because they don't want to write add a number after dot dot dot. That's why I just feel uncomfortable with this. People write c right there. It'll be better. Because when we do integration before, we usually write c at the end, right? It's okay to write c in front. And c is 0, so you have this. Okay. Let me see if any other type of problem that we need to indicate in here. That should be it. How about let me give you one more example. Try one more. Make sure you guys get it. I just want to give you more examples. Make it better. Let's do one more example. I'm looking at the exercise in our book, and I'm gonna just pick another problem. Okay, choose one. I choose an easy one then. Find the power series of the function f of x equal to tangent inverse of x. Okay? So usually you try to take, you have no clue what is tangent inverse power series of this. You can think of what? Find the integral of this or find the derivative of this, see how it looks. Okay? So in this case, I see right away that f prime of x is tangent inverse of x, derivative. And you know the derivative of tangent inverse is 1 over x squared, 1 plus x squared. X squared plus 1, that's what I say, but try to write 1 plus x squared, make it look like what we learned before. Okay? And we know the power series of this one already, which is, what was that? 1 minus x squared plus x to the 4 minus x to the 6 plus x to the 8 minus x to the 10 plus x to the 12. Okay? Keep going. So, you know the power series of the derivative of tangent inverse. And by the theorem that we just learned, we can find the power series of the original function. So, f of x is the integral of f prime of x dx, right? We find the antiderivative of the derivative function. It's going to go back to the original function. Okay? Which is antiderivative integral of that thing right here. Now, I'm lazy of writing all the integrals, so let me just do the integral, okay? Integral of 1 over 1 plus x squared dx, which is what? Integral of 1 is x. It's x squared, so minus 1/3 x cubed plus 1/5 x to the 5th minus 1 over 7 x to the 7 plus 1 over 9 x to the 9 minus and then plus c. And again, I don't feel comfortable to have to c at the end, so let me write a c in front. Okay? So constant. Don't forget when you do the integral, you have a constant. And the whole thing is tangent inverse of x. So you almost have the power series. All you have to do now is take care of the constant, right? How do we find a constant? Just plug a value in for x, and the best value to plug in is what? The center. In here, x equal to 0 is the center. X equal to 0, then tangent inverse of 0 is equal to 0 because tangent of 0 is equal to 0. Okay? And this is equal to what? When we plug in x equals 0. The whole thing 0, 0 and equal to c. Okay? C plus 0 minus 0 plus 0. So tangent 0 is 0. So c equals 0. So you have c equals 0. You have the power series for tangent inverse of x, which is x minus 1/3 x cubed plus 1/5 x to the 5th minus 1 over 7 x to the 7 plus the you have the power series. Okay? So please try your homework, and it's going to see more type of functions, more type of problems. You just keep going around from the original function, modify it, or taking the derivative, or look for the integral. I actually, to be honest, you look for the second example and find the integral, find the derivative, the opposite of this. But I couldn't find any example in our book. They just have the original function. You take the derivative, you have the power series. I was looking for the problem. You have the function, and then you integrate it. You have the power series, so you can go backward of this. But I couldn't find one at the moment, so I chose this example as a second example. Okay, but the idea is similar. So please practice, and as usual, have a question, feel free to ask me anytime. Thank you for watching, guys. Have a good day.